Hi everybody. Today I thought I'd share with you the process I go through when I'm making a printed circuit board. This may also be useful for the hobbyist for any project where you need a custom-made PCB. Now I'm currently working on the voltage reference standard upgrade that I did in my previous video and for which I wanted to make a printed circuit board. So what I'm going to do today is just share with you the process of manufacturing that board from start to finish. Now to start with, I'm going to use some transparency film, inkjet transparency film that I can use on my inkjet printer, and I'm going to print my PCB design on this film. And this type of material, it's got very glossy on one side and it's a little bit dull and matte on the other. And you need to ensure that when you're printing on this, you print on the dull matte side, and you set your printer to print on transparencies in the settings. Well, here's the printed circuit layout now, which I've printed on a inkjet transparency film, and although you can see it's the right way around, we actually print a mirror image of this on the other side. I'll just turn it around. So we actually print on this side here, and we print a mirror image, and that's what goes up against the printed circuit board, so you get a sharper image on your PCB. Right, here's the printed circuit board type I'm using today. It's a fiberglass board, and on the reverse side we have a photographic film on that side. At the moment it's got a black plastic sheet over the top of that to protect the photo etching surface. I have a small piece here which I can just demonstrate. Prior to putting it onto the film with your printed circuit design on, you simply, in a darkened room or under a red photographic light, you simply peel off this black sheet. So this is a sample here. You peel off the black sheet like this, and that then reveals the photographic film on the reverse side of the board. That's been sprayed on top of the copper, and then basically what you do is you turn it around, and that then goes on top of your film with the printed circuit board. Now it's important that you ensure that before you expose the photographic PCB to the ultraviolet light through this printed circuit film, make absolutely sure that it's the reverse image that you're looking at, and this is easily done by just looking at the printing I have here on the printed circuit board. You'll see Scullcom Hobby Electronics and some more printing at the bottom. You'll see that that's looking as a mirror image as you look at it. You then know it's the correct way, and the PCB, once you've peeled off the black film underneath off the photographic surface, the PCB then just sits on top of that once you've cut the PCB to the right size for that. The next thing we'll do is we need to cut a piece of this photo printed circuit board to size. So let me just measure that, and then we can cut it. Well, that's the length, so we can cut that first, that piece first. Right, I use a right handle metal set square here and a Stanley knife to score the PCB. And if you keep doing that on one side, then we do the other side, and then it should just break apart. just mark the edge on both sides, and then we can score the other side of the board. And then we score this side of the board on the print side. If you go over a few times until you've cut through the copper print. Right, once you've scored it through the print on that side and you've done the other side a few times, then simply, if you bend the board, you should be able to break it. Okay, right, that's one side cut, so we'll just measure the width and then we'll cut that down to size. Just marking the width now. And we just mark this, and then we can just cut that little piece off the same way as we did on the other one. Sometimes when you have a small strip to cut, you can actually cut it with some wire cutters, strong wire cutters. Right, that should be nice. You can file the edges down so they're all nice and smooth, and then we've got our board there. Here you can see the ferric chloride granules I'll be using today. These are to etch the copper off the printed circuit board. Quite cheap to buy these. I buy them in bags of 500 gram, and this will dilute with 3/4 of a litre of water, hot water, until it's all dissolved, and then you can use it in a tray to etch the copper off the printed circuit board. Here is the Photoresist Universal Developer powder, the white powder, it's very tiny little granules really, and this pack dissolves in about half a litre of hot water, and then it's ready to be used to develop the photoresist on the back of the printed circuit board. Right, the next thing we'll do, we'll just set up the ultraviolet box I have to expose the printed circuit board. This is a homemade one I made with some UV tubes, and I used the top of an old scanner. Probably show you this, how to make one of these in a later video. So there's a glass top here, and I have some UV tubes in the bottom there. So it's just a homemade affair this, but it does serve the purpose quite well. So the first thing we need to do is put the printed circuit transparency on top here, on the glass here. Now remember, when you place the printed circuit transparency on the UV box here, to put the transparency so you have the mirror image facing up. And then I would recommend then that you tape down the transparency to stop it moving. Just a little bit of tape. I'll just zoom here so you can see exactly the way I've got the transparency. Right, here you can see I have the transparency now on the glass here over the UV tubes. And the important thing here is you see that we have the mirror image facing upwards, so that's what goes against the printed circuit board. So if you look there, you'll see that you've got a mirror image of the text there. Right, the next thing we'll have to do is place the printed circuit board on exactly over the top of the transparency there, but obviously I need to peel back this protective film here that's over the photoresist material, but I need to do that in darkness or under a red photographic light. So what we'll do next is I'll switch on a red light that allows us then to peel back this protective film, and then we'll go through the process of putting it on top, closing the lid, and then we expose it for exactly 1 minute. Right, we have the lights off now, and I have a photographic red light which I can now use to see what I'm doing without affecting the photo etch material on the back of the printed circuit board. I'm going to use just a little kitchen timer set to 1 minute to time the exposure to the ultraviolet light. Right, the next thing we need to do now is, there's the printed circuit board. I need to peel back the protective film on the back of it. Just ease it off with a little knife, and then I need to peel that off. And then place the print side exactly over the printed circuit film there. So make sure you position it correctly. I've got a few guidelines there as well to help me do that. So you can see there and here, you can see I've got some guidelines there to help me just position the board. Well, that looks fine. Right, what we'll do now, we'll close the lid over the unit, and we simply now need to switch it on and time it for exactly 1 minute. Now what I found is that exposing this for around 1 minute is probably about the right time period for these photoresist printed circuit boards. If you overdo it, then you find that the results are not quite as good. If you underdo it, it's also not as good. So the timing is quite critical, and I found that exposure for exactly 1 minute is just about the right time for these boards. And then once we've done that, we'll switch off the UV tube here, and then we'll have to develop it in the developing liquid, which I'll show you in a second. Just about there. Right, I'll switch the UV tube off now, and the next thing we need to do is still keep in the dark, and we need to take the board out and put it straight into a developer. Right, here you see now I've got the large tray here has got the developing liquid in, and the small one there has got some cool water in there to wash it after we've developed it. And I've just got a timer here just to keep track of time. It's usually about 30 seconds to a minute to develop. You have to be careful not to overdevelop it, because you could then just eat away at some of the printed tracks. It's also advisable that you wear some disposable rubber gloves for doing this job as well. Right, well, let's now pop the board into the developing fluid, and I'll do it so the print surface is facing upwards so we can see it, the process. And I'll just set the timer going just to keep a track of the time. I'll just try and get a bit more light on it so you can see. I usually find just rubbing it down with your fingers with the rubber gloves on helps. The other point I would mention is if the developing liquid is cool, it does take longer to develop than if the developing liquid is warm. Just rotate it a little bit about in the liquid. you should start to see the printed circuit layout coming through shortly. This liquid at the moment is a little bit cool, so it will take a bit longer to do. You can now just about see it starting to show the print. A little bit longer. You'll see where the grey areas etch away still. You just want to be able to see the printed tracks, that's all. Just a little longer. The liquid's a little bit cool today here, so it's taking a bit longer than normal. If the liquid is sort of at room temperature and warm, then it should normally do it in about a minute or so. You can see now there the board is just about starting to develop the printed circuit. You want to clear all the areas away in between the tracks, make sure there's no dark areas between the tracks to make sure it's fully developed. Just rotating it, moving it, agitating it a bit in the developing fluid. Nearly there. Just see a few little dark areas. I think that's just about developed that now. Just a little bit there. Well, I think that looks fine at the moment now. I think that looks as though it's more developed. So once we're happy with that, we then rinse it in the cold water. Right, so I'll rinse it in the cold water now. Now once you've put it into the cold water, we can now switch the normal lights on, so we can probably see what we're doing now. Right, there you can see the board now. It's developed. We're just rinsing it in some cold water. I'll just take it out so we have a look. And that looks fine. So there's our printed circuit board, which has been developed. So all the copper, you can see all the copper now, which we need to remove with the acid, and the tracks are protected now with the resistive film there. So the board is now ready for etching. We just dry it off first, and the next process is to put it with the acid to etch away the copper and leave us with the printed tracks. Now, one thing I should say, the developing fluid we have here, you can use this again. What I normally do is I save the developing fluid in a bottle, and I can use it again. It does last quite a while, so you can probably keep it in a bottle for a few months and just use it several times. So I'll just funnel it into this bottle here. There we go. Ready for next time. Well, now here we have the tray in which I have the ferric chloride solution. Now you need to be very careful with this, and also you need to be in a well ventilated area when you're doing this process. I would also strongly recommend that you use some disposable gloves, because don't forget we're working here with acid. So before I get involved with the acid, I'll put the gloves on. But before I do that, the printed circuit board here, which has now got our photoresist protecting the printed circuit track, the copper's all exposed. What I want to do now is on the top side I'm going to use some insulation tape so I can hold the board. And we simply just stick the tape on the top side of the board in a fashion where it allows us to use it to pick up the board. So basically it means I can now hold the board with the tape. So now I'll just put on my disposable gloves. And to etch the board now, we need to put it into the solution. Now the way I would recommend doing this is to float the board on top. In that way the copper that's etching from the board is then falling away from the board. And the other advantage with this method is that when the board is etched, you'll see the printed circuit coming through the board, so you know when it's done. Now the other thing you need to be careful of is not to get any air bubbles between the board and the fluid, and the way to avoid this is when you put the board in, just tilt it at one end and then just let it down slowly until it floats on top. When you've done that, you can then just carefully lift the board and have a look underneath the board to see if you have any air bubbles. We had an area there, so what I suggest you do then is you hold the board, just dip the board in gently on top, then pull it off again and make sure that the fluid is coating the whole board. Then what we'll do is tilt the board again at one end and then lower it at the other end till it floats on top. And let go, and the surface tension will hold the board in place floating on top, and the copper will now etch away and fall away from the board. When the board is done, you'll see the copper coming through the top of the board there. Now one thing to be careful of is that if you get any fluid coming over onto the top of the board, if the top of the board gets wet, then the whole thing will sink because it's been held here with the surface tension. So you need to be careful to keep the top of the board dry. So let's now leave the board there to etch. We can go away and have a cup of tea now, and we'll come back and have a look at it when the board is etched. Well, it's been about an hour now in the acid there, and you can clearly now see the printed circuits appearing through the top of the board there. I've noticed that there's just a few little patches here and there where the copper hasn't fully etched away, so I think it needs another 5 or 10 minutes and then it should be fine, and then we need to take the board out and then rinse it in some clean water. So let's just leave it for another sort of 5 or 10 minutes, then we'll have a look at it. Right, looking at the board now, it looks as though it's more or less okay now. Can't see any other bits coming through. So I've just put disposable glove on again, and I'll just pick the board up and have a look underneath, make sure that it's okay, and then we can wash it in the water here. Oh, a close look, that looks fine. You can see the red tape coming through, but that looks fine. So we'll now give it a rinse in the water. I'll take the red tape off. And we just rinse it thoroughly in just cool water, just to get any of the ferric chloride acid off, and then we can dry it. Well, there we are. There's our printed circuit board. We still have on the board itself, you still have the photoresist on top of the track, so the next thing we'll have to do is clean that off. But the board itself looks fine. Now, what I find the easiest thing to clean off this photoresist on the board to reveal the copper, I use some isopropyl alcohol spray. You don't have to use this, you can use any other sort of alcohol type cleaning fluid, but I find this is very good, and just spray a little bit on the board and then wipe it off with a tissue, and you'll get rid of all the photoresist coating. Right, there you now see we've cleaned off the photoresist coating there off the board, and we've now revealed the copper printed circuit tracks. So that looks fine. The next thing we need to do now is simply drill the holes, and all the holes are clearly marked on here, so you need to just drill them, and then we'll have a completed printed circuit board. To drill all the small holes for the components, the resistors and capacitors, etc., and transistor, I'm going to use a small little tungsten drill bit here, which is 0.8 of a millimeter in diameter. And then for the larger holes, for the FET, the MOSFET, I'll be using a 1 millimeter drill. And then for the rotary switch there, I shall be using a slightly bigger drill to fit the size of the switch contact pins. And then the holes there for the banana sockets, if I remember correctly, I think they're around 6 millimeter holes I need to drill there. So let me go away now and drill all the holes, and then we'll come back and have another quick look at the board. There's the printed circuit board now with all the holes have been drilled. There were 6 millimeter holes for the banana sockets, and for the MOSFET and for the tactile switch I used 1mm drill bits, and I used a slightly bigger one for the pins for the rotary switch. So the next thing we'll do is we'll give it a final clean, and then we'll spray the print side with some flux. Right, I've cleaned the copper on the board now, and I'm going to use some flux spray. This sort of thing I use, and I just give it a spray on top and then dry it with a hairdryer. So the final thing now is we'll just give it a quick dry with a little old hairdryer I use here. Right, well, here we now have the final printed circuit board we've made today, and just one little tip really: when you're handling the board, when you're making these PCBs, try and avoid fingering the print side of the board where we have the ultraviolet resist on the board, or even the copper, because when you're actually processing the board, when you're making it, any grease on your fingers will affect the process and make it a little bit more difficult. So try and keep your greasy fingers away. If you're wearing disposable rubber gloves, then that obviously solves that problem. And the other point I would make is that the solutions that we use today, the speed at which they work depends on temperature. So the cooler they are, it takes longer for the reactions to happen. I sometimes use that to my advantage, because when you're developing these boards, and you're developing after you've exposed it to the UV light, if you develop it too quickly, you can lose control. So I like to sometimes develop it with a cooler developing solution that gives me more control over the way the board is actually being developed, and I have a slower process which I can just keep an eye on it. So that's just a little tip that you might want to take into account. Well, I hope you found this little video on how to make a printed circuit board useful. I'm sure that some of my future projects, where I'll give some little PCB layouts for you, it can also come in useful there as well. So many thanks for watching. If you found this useful, please give me a thumbs up, and I'll see you all again next time. Bye for now.